Welcome to Chibuzor Mathphysics. In today's video, we are going to be dealing with the mean, the median, and we've got a question that we are to handle, and we are to find the mean and the median. In this question, 200 candidates took each of 2 examination papers. The diagram shows the cumulative frequency graph for their marks. Use the graph to answer the following questions. We are to estimate the median mark for each of the paper. Here is the graph. We've got the cumulative frequency to be from 0, 25, 57 up to 200. And if you observe critically, you will see that in between 175 and 200 is the first paper. The second paper lies between 150 and 75, and you can see the graph moves instantaneously. It is not a straight line graph, and we have the marks to be ranged from 10 up to 100. So we are to use this graph to find the estimate of the mean, the median mark for each of the paper. For us to do this, it is a prerogative for us to understand what exactly is a mean or a median. When we talk about a median, the median tells you where the middle of the data is, or we can say it tells you where the middle of a set of a data set is. It is used for many real life situations, like when we talk about bankruptcy law, where you can only claim bankruptcy if you are below the median income in your state. So that's exactly what we do in median. So usually for us to calculate the median, we use the formula n plus 1 divided by 2. So usually the formula for median is given by n plus 1 divided by 2. N plus 1 divided by 2. Of course, we know that n is simply the number of items in the set, and that number of items in the set plus 1, then you divide it by 2, will give you the median. So let us look at what we have and then see how to find the estimate median mark for each of the papers. Stay tuned and enjoy. I remain your friend, Augustine Galagash. Don't forget to subscribe to the channel. So to find the estimate median in this graph, the estimate median mark for each of the paper, if we look at paper 1, look at this paper critically, you will observe that the cumulative frequency for paper 1 ends between 175 up to these 200, but we are estimating the median mark. So the median mark, so we focus on the median mark. If you look at the median mark for this estimate, you observe that for paper 1, the median mark ends at 70. 70, but there is an addition, so it is like 70 plus 3, so that will be 73. Let's say 73. If you 73 plus 1, according to our formula for median, will give you 74. Divide that by 2, you get 37. So 37 approximately, because there is one more there before 80, so that will give us 38. So the first median for this graph, the first median will be median 1. Let's have a solution. So solution, median 1 median 1 will be equal to 38 approximately, the estimate mean. So this will be 38. So what will be the median 2? The median 2 will be taken from paper 2. If you observe, paper 2 has gone beyond 100, and from here we have got 100 plus 3. This is 103. So simply have 103 plus 1 will give you 104. 104 divided by 2 will give you 52, but this is the last interval for this. And if you observe, we've got 10 interval each, from 0 to 10, from 10 to 20, 20 to 30. So since from here we've got 100 plus 3, if we add 1 we got 104, divide by 2 you got 52. But if you estimate another interval which is 10, simply add 10 plus 52. So 10 plus 52, 52 plus 10 will simply give you 62. It therefore means that the next estimate will be between 62 and 61. So the second median from paper 2, median 2 will be equal to 61 if we estimate that. So we will get 61. Therefore, we've answered the first question, that we estimate the mark for each of the papers. So the paper 1 is 38 and paper 2 is 61. So that answers the first question. Now let us consider the second question. The second question states with a reason which of the two papers was the easier one. Which of the two papers was the easier one? We know that median 1 is less than median 2. Median 2. So since median 1 is less than median 2, because median 1 we got 38 and median 2 we got 61, so it therefore means that paper 2 is easier. So the reason will be that median 1 is less than median 2. So we conclude that paper 2 is easier. So that will be the answer to the second question, and that will answer this option B. So let's look at option C, where it is suggested that the mark of paper on paper 2 were less varied than on paper 1. So use interquartile range to comment on this suggestion. And you know the solution, the formula of interquartile range. Let us look at paper 1 interquartile range. So interquartile range is usually represented with Q. We represent interquartile range with Q. Of course, when we talk about, we'll have Q1 and then we will have Q3, Q1 and Q3. So think of Q1 as a median in the lower half of the data, and when you talk about the interquartile range tree, you think of it as a median for the upper half of the data. Now if you don't know how to find the interquartile range, I will refer you to my previous video. But in this video, if it's the median in the lower half of the data, you will discover that we've got 25. 25. Of course, even if you minus 200 in 175, you will still get 25. So this therefore means that Q1 in paper 1, so Q1 will be equals to 25. and Q2 will be equals to 55. Of course, it is Q3 minus Q1. This will imply that 55 minus 25, that will give us 30. So therefore we can say that for paper 1 we have 30. If we do the same in paper 2, for paper 2 we take the lower limit, that will be Q1, which is equals to 46, and Q3 is 70. Q3 is 73. Because of time, we will just finish up with this video. I will refer you to the previous video where I did introduction on interquartile range. So it is 73 minus 46, and this will give us 26. So it is 26. Therefore we can say that interquartile range Q3 minus Q1, 30 is greater than 26. So 30 is greater than 26. So we can go back to our question. Question option C. Option C, we know that 30 is greater than 26. And if 30 is greater than 26, what does that imply? So paper 2 is less varied. So we can conclude that paper 2 is less varied. It implies that paper 2 is less varied, because we are to find out why paper 2 were less varied than paper 1. This is because 30 is less than 26, and this is how we handle that question. Let's go to option B. Option D says the minimum mark for each grade and on paper 1 was 10 marks lower than the minimum mark for grade A on paper 2. Give that 25 candidates gain grade A in paper 1. So we have to find the candidate who gained grade A in paper 2. To do that, in this fourth one, we are going to use the cumulative frequency. So let's go back to our graph. So if we look at the cumulative frequency for paper 1, it lies between 175. You see, we have 175 and then we have 200. Paper 1 lies there, so we can have 75 as a cumulative frequency that lies between 60 and 70. That is 69. That is 69. That implies that let us have a pen. The total number of people who gained grade A in paper 1 will be equal to 35, because we know that the cumulative frequency 1 is 175. 175, while x1 lies between 60 up to 70, which is 69. So it is 69 plus 10, because the interval is 10, that gives us 79. But we know that the cumulative frequency of the second paper lies between 165, that is between 150 up to 165. So we simply take 200, which is the highest number here in the cumulative frequency, minus 165, that gives us 35. So 35 is the number of people that gain grade A, and this will answer the option D. So the last one is asking for the mean, the standard deviation. So let us do that as we conclude in this video. So algebraic expression using this formula for the mean, and we are able to find the variance, and then we find the standard deviation, which is the square root of the variance. So the standard deviation is simply 28.2 while the mean we have 28.2 the variance. So this is our computed answer.